Welcome. I thought I would do a site visit video now that I have finished the waterproofing and the perimeter drainage. It's July 28th, 2015, and this is for record and also for the general interest of the viewing public. So we're at the southwest corner of the dwelling, the furthest point away from the sumps, and I learned this from a builder friend of mine. Tie the two runs in together, but still have a directional clean out. So this is going to the north and that's going to the east. The piles of gravel are just to secure the pipe every so often so that it didn't rise as I was putting the next links in. All of each individual run was leveled to 0.5, 0.6 percent. I've also put a hose in the two cleanouts and guaranteed that the water flows out to the sump. So the system we have is a fast foot footing bag. I would not do that again, and I'll describe it more in a review I'll do on the foundation system. It is very vulnerable to damage, and the rounded footings are very difficult to deal with, and it just makes it much harder to do all of the steps post pouring compared to a conventional footing that is formed with wood. What I would do next time is I would pour the footings and with using conventional lumber, and while they were wet I would embed a membrane horizontally across the top of the footing and use a keyway instead of dowels to ensure that the foundation has anchoring onto the top of the footing. So we've got a fast foot footing form. We have a transitional membrane. It's called Flam Stick from Suprema. It is a peel and stick on the bottom side and a torch-on surface on the top side. That allows us to transition to our another product from Suprema. It's called Torch and Stick. It's Sopraline, I believe. I'll correct it with a text on the video if that's incorrect. And that goes right to the top. We are going to waterproof that top curve later on when the backfill is generally complete, so that we can be working from a grade instead of on a ladder. There's a lot of work to make the membrane go around those shapes, and I've got some cleanup to do as well, for instance up there. Okay, so proceed around. Got geotextile that's going to be between the gravel and the backfill. So what happens now is we're going to have a torch on, or a Roxol mineral wool insulation that is going to get adhered to this. You apply a little bit of a torch to this and the top surface melts, and then you can adhere the Roxol into it. That's what it's actually meant for. And then we'll have a dimple board, and then 6 to 8 inches of gravel, and then we'll have the geotextile, and then the backfill. Okay. All the little spots you see on the membrane, the fast foot membrane, are spots that I had to repair after the fact. I generally found that the easiest approach was to take a piece of the torch-on membrane and take the torch to the membrane itself, let it cool down a little bit, and then stick it onto the membrane. That was faster and easier and more surefire than you can see it's well stuck, than the priming and putting on a membrane of a peel and stick variety. And never mind using the tuck tape, the red tuck tape. It doesn't stick at all over time. Okay, and so now we're on the front east face of the house. This was the ramp to take the tractor out. Elfie. And this will be a clean out as well. I haven't been pointing out the clean outs as we go, but again, they're all directional. And this one is going to go and be rooted into the garage wall so that it's hidden. And the storm leader from the roof is also going to be rooted the same way, so that I don't have a clean out and a gutter right at the front entrance. And you can see that the Tortron membrane adhered extremely well. The wall was first primed with Sopraline 500, I think it's called. Again, if that's not correct, I'll post the text. It's a emulsion sort of asphalt that gets primed onto the surface, and then this gets torched on. And what we did is we adhered it about halfway point and then rolled it up as we torched it, and then came back and did the bottom half. And yeah, it's adhered extremely well. You can tell there's no hollow spots at all. This was an area where the ramp had caved in fairly soon after excavation, so it took quite a bit of digging to get through all this muck. There's at least 3 inches of gravel below the pipe as well. I have the holes facing down, that way I did that so that there would be a minimal rise in the pipe above the footings. I wanted to keep the pipe as deep as possible and the water level draining as deep as possible, but that does mean that you need a healthy granular base below the pipe to ensure that no fines come into the pipe. And then step around, now we're at the east face of the garage, and we've got positive slope all the way to the to the sump. And where the pipe goes into the sump, it's cemented into place with non-shrinking grout. I also took the opportunity when I rented the hole saw to put in the lines for the 2 electrical conduits, one for the floats and one for the power, as well as the one to the right and lower is going to be the main pump out. It's a 2.5-inch line that will be 3 feet below grade, and it'll pump over to the shallow sump that gravity feeds to the municipal storm. And at that point it'll come out from the 3-foot below grade mark to about a 1-foot below grade mark, because I have a really shallow storm sump to the municipality. So we're back at the southwest corner, and I will now show the north run of the pipe. So the bend here was an area where the footing bag had moved. During pouring, it shifted. Fortunately, it was a low stress area for the foundation, so the engineer accepted it. But another demerit against the footing bag. Going along the west wall, all back here is all of the dirt that I had to, you can see all the dirt I had to excavate to put the drainage in. So areas where I was below the existing granular level that I had dug in earlier. And going around the jog by the tree, we're now at the northwest corner. This was very tight to do the torch on. You can see here, I mean, we're basically almost 2 hand widths here. Corey, the torcher, was not impressed, but we got her done. The corners are done. What we did is we brought the membrane both ways into the corner, and then we just lapped smaller pieces bottom to top, and that was much easier to detail than trying to get one of these sheets around. And I also did the same kind of detail with my membrane, the transition membrane, and did a couple of darts so that it conformed. If you round the edges, like the top and the bottom edge, it conforms a lot better to a curved surface. Okay, so we're now going to go down the north wall. Got a cleanout that's going to go up to grade. I basically put cleanouts wherever I'm going to have a storm leader, riser, and cleanout, and that way I'm grouping them together. I also did them where there was a significant change of direction to aid in cleaning out the system if it's ever needed. So this jog around here is because for the rest of this area is the footing and slab for the basement walkout. And the depth of the footing slab is such that this drain pipe would be going right through the middle of the slab. So I'm diverting the perimeter drain around and to the outside edge of that the foundation for the walkout, which would have needed a pipe anyway. And then this whole area is really a deep granular level, so it doesn't really need any piping at all. We're draining the granular plane itself. But then I've also got a little tiny sump for the drain at the bottom of the stair walkout, and it's down. But there's another, in some cases, 1 foot to 1.5 feet of gravel below that pipe that will be draining. And so this is just blocked up because there's an extra hole that has to be filled in. But later on, that 90 elbow will be facing downwards here, and it will be a dry fit so that it can be removed to aid in cleaning. And the reason for the elbow is that as the water level rises, it keeps the leaves and other debris from floating into the piping system. So again, we're in the basement walkout footing area and slab. The footing and slab are one of the same because the property line is basically right along the base of here. Those blocks are mainly on the neighbor's property. We didn't have enough extension beyond the foundation to counteract the moment of the lateral forces that the foundation and the backfill is going to create, so we had to create all of that mass on the inside of the foundation. And so I think it's a 10-inch thick slab slash footing that's going to be along through here. And so we're now at the business end where everything drains, so that basement walkout slab drain is here, goes down. And the reason it goes down is because I am draining the granular layer on this site. I don't anticipate that the drain pipes themselves will ever see moisture. And in fact, I should have pushed a little bit harder. The code actually allows for there not to be drain pipe if you do have a healthy granular layer that you're draining, and it would saved me a few $100s and some effort putting it in. But c'est la vie, it's in now. But you can see that the comparison between where I would typically be draining to, that would be the water table. I'm bringing the water table down another 2 feet down to that point, and there is a steady flow of water that it's hard to see now, but you can just see it coming through. It's coming through on both sides, and all the groundwater is flowing into there. I put the holes up at this particular location just for the last 3 feet because the glacial till below that pipe is very difficult to dig, and so there's no gravel under that pipe. The pipe's laid right onto the glacial till, and it was far too confined quarters to be digging down another few inches. It's taken enough effort to dig this pit with all the gravel that was here. I've had several cave-ins until I figured out where the plywood needed to go to hold back. This is a 45 angle of gravel that the geotech required because there's a lot of groundwater coming out just behind that sump, and it was eating away the bank. But so there we have it. We've got our 3 inlets. That's the south circuit, the north circuit, and then the circuit feeding the basement walkout slab drain, as well as the granular fill layer. And where you see that joint, the sump actually goes another 3 feet below that. Less about 8 inches for the poured bottom of the sump, but it's a 3-foot tall module. Okay, so I hope you've enjoyed the update. Next is going to be installing the rock salt onto the exterior of the foundation. I'll check all the seams at that point to make sure that they're all tight and repair any that require it. And then hanging some dimple board onto the outside of the rock salt, and then starting the gravel and geotextile and backfill procedure. Thanks for visiting.